All right, good morning, good afternoon, and good evening, and welcome back to another episode of IT Pro TV. I'm your host, Don Pizzette, back again with Mr. Ronnie Wong. How's it going, Ronnie?
We are doing well today. We have used none of the Beastie Boys songs in any of our advertisements here at IT Pro TV.
That's important.
So we're doing well.
You know, it's amazing which bands decide to apply their intellectual property the way they do, but yeah. The Beastie Boys of all bands. All right. So today we are going to be continuing on with planning, and you might ask yourself, "Come on, guys, how many episodes are we going to do on planning? Eventually, we got to do something, right?"
More.
Well, yeah, we got more. So it's a lot, right? Planning is a big part of what we do as project managers, and it's a big part of the exam. So that's why we continue on. Fortunately, we are starting to wind down, right? Let me bring up my PMBOK and get to my good old process groups. Sorry, just a second. There we go. And basically, we're starting to wind things down. We got all the way through our scope management, time, cost, and now we're going into these last couple of ones, which are pretty short with the exception of risk, right? There's a lot involved in risk, but the other guys are pretty short. So today, it depends on how time goes, but we're going to shoot for the triple threat. We're going to try and knock out quality management, human resource management, and communications management today. We'll see how it goes, right? Sometimes I ramble on too much, and then we might have to do part two, but we'll see. So we're going to start out right here with this guy, which is plan quality management. Now, quality management is kind of a weird topic because it doesn't apply to every industry. And so I go back to what I said in episode number 1, which was the PMI framework is a modular framework. You pick and choose the things that you need in your company, and the things that you don't need, you cut them out. You just throw them on the floor and that's it. And so quality management is one of those where you may not need any kind of formal quality management. You might lop this out and it's gone, right? So how do we know if we need it or not? Well, we start by saying, what is quality management? What the heck am I even talking about, right? If your project involves the creation of a physical, tangible item, there's going to be specifications that item has to meet. Right. And our quality is how well we met those requirements. Now, if we're talking about process improvement or a service, it's a little bit harder to measure, right? But pretty much everything can be quantified. If our project is to improve the efficiency of let's use a real world example. This was done years ago. There was a project to improve the efficiency of the McDonald's drive-through. Right. How to make the drive-through get people through faster. So they did studies, they did some prototypes, they tried some various things, and at the end of the day, they decided it would be best to add a second drive-through window. So you had a window where you paid and another window where you got your food, right? And they found that got people through the drive-through faster. They were able to measure that by measuring the amount of time people spent in the drive-through. You improve the quality of the customer experience by making that time shorter, right? Now, there's always room for improvement. We have this concept called continual improvement or continual process improvement, which is stating that you're never really done. You can always make things better, right? But when we're dealing with a project, we're not necessarily making something better. That's not necessarily what our project is. Maybe we're creating something all new, in which case we just have a set of requirements that we need to meet. And in the IT world, we're not normally doing quality measurements like these. We're normally meeting our requirements, and that's that. But if there's something that's subjective, if you're creating an advertising campaign or something, then you're going to need ways to measure quality to ensure that you meet your customers' needs. So planning quality management is creating our quality management plan, and it's basically saying, how are we going to handle quality for our project? And then you'll see perform quality assurance and control quality, where we actually implement that later on. And in fact, if you look at all three of these, unlike every other one we've done so far, where you created a plan and then you had other things that you did, right? So plan scope management, plan schedule management, plan cost management, but then they had other things. These next three that we're going to do, the quality management, human resource management, and communications management, we're just coming up with a plan right here. That's it. That's all we're doing at this particular phase in the planning model. And that's because we can't really do much with these until we're actually executing. We can't manage our human resources until we actually have the human resources. And we don't need those people until work starts, right? Same thing with communications. We don't need to communicate with people until work starts. When we're in the planning phase, we're talking with our project management team. We're already in communication with them. So these 3 phases are a little bit special in that we're just kind of coming up with how we're going to manage these things when we get to execution. All right, so let's take a look at planning quality management. Planning quality management, it's a pretty standard process for us. On the input side, we've got our project management plan if we have one, because if we already have a project management plan, then we've already planned for quality management. We've already designated how we're going to handle it. We're kind of done. All right. But if we're having to create this ourselves, then we're going to have to get information from other places. Our stakeholder register, that's going to identify the people that are involved, the people that I need to reach out to are going to have the information that I need as I figure out how I want to do this plan. My risk register that I know we haven't talked about yet, but listing the various quality concerns that might happen as part of our project. Our requirements documentation. How do I know whether I'm meeting what my customer wants? Well, the requirements documentation is where that data is found, so I need to go and look there. And then our 2 favorites, enterprise environmental factors and organizational process assets, same as they always are. Any regulations I have to meet and any paperwork, documentation templates, or whatever that I've already got as part of the company. All right, then we start to apply the magic. The world of quality is a very complex and advanced world. You have a lot of organizations out there that have quality managers, that have people that have PhDs in quality management. This is a very, very robust field. But with PMI, we're concerned about the project, right? So we reduce it down to what looks like a very simple thing. It's actually a pretty complex topic. Fortunately, we don't have to go too crazy on it. So what we're going to do is we're going to look at some of the various ways of managing quality, some of the various tools that are available out there. And again, you just pick and choose what it is you want to use in your company. All right, the first one is one of the easiest. It's what's called a cost-benefit analysis. There's a lot of things that we can do in our organization to make something better, all right? And it's up to us to choose whether or not we want to do it. And it often comes down to something very simple. We look at how much it would cost us to do something and what benefit we would get out of it, all right? And sometimes you'll find that the benefit is greater than the cost and it makes sense to do it. Other times the cost is greater than the benefit and it doesn't make sense to do it, all right? Let me give you guys an example. Here in the studio that we're in, all of our electricity is provided by the electrical grid here in the city of Gainesville, right? So we have no alternate energy solutions here in the building. So let's say we wanted to change that. We want to put solar panels on the ceiling, or on the roof, I guess wouldn't do so good on the ceiling. So we'll put solar panels on our roof that'll capture the sun's energy, convert it to electricity, and maybe offset some of our electrical costs here as far as powering our lights and all of that, all right? Well, the solar panels cost money. The electricity cost money also. So by installing those solar panels, will I save at least that amount of electricity? You know, my electric bill, will it go down by that much to offset the cost? Or is offsetting the environmental footprint enough for me, right? Maybe I'm really, well, for those who know me, I'm not very upset, but let's say that I'm upset that we're burning too many fossil fuels or whatever, and I'm worried about the environment. And so I want to reduce our environmental impact. I want to reduce our carbon footprint. So I want to put those solar panels up. And it's not a matter of money to me. I'm not worried about how much those solar panels cost. I'm worried about how much I can help the environment, right? So is that the best thing to help? Would wind turbines be better? Would, what else do we have, Ronnie? Biomass?
Yeah.
You're going to do a biomass thing, right? Which one is going to give me the best improvement over whatever my goal is? Now, I use the example of environment. I've never dealt with a project that dealt with environment, but what I normally dealt with was money, right? Everybody's concerned about money, your bottom line. And we actually did a little study right here just a few weeks ago. We have some servers in place, and our general manager came to me and said, "Don, those servers are getting kind of old, and I think we should replace them." And I said, "Well, they're getting kind of old, but they're not used for anything production. They're our test servers, and they work fine. They're not under warranty, but I'm not worried about that. We don't need to replace them." And he said, "Well, Don, they're old, so they probably draw a lot of electricity. I bet if we put new servers in, they would save enough electricity to pay for themselves." And I said, "Philip, you're crazy. That's not, I can't imagine those servers draw enough power." So he went out and he purchased a little device called a kilowatt, and you plug it in between the server and the wall, and it measures the electrical draw. And so he did that. He monitored it over a period of days, what each power supply of those servers would take. And then he took it and he ran the numbers he got against our electrical bill to find out what those servers cost us. And each server, so there were 3 of them in this case, were costing us about $600 per year in electric, which was way more than I thought it would be. So I was wrong. I thought it would be way less. $600 per year, right? So at $600 per year, let's think about the servers. So here I'm gonna bring up just a blank notepad, and I'll show you guys how a simple cost-benefit analysis works. All right, so the old servers, they basically have an operational cost of $600 per year just for electricity, right? So that's our old servers. We could get new servers, and the new servers, prices have come down, technology's advanced, and so these older servers that we have, I think we paid about $6,000 for each of them, and there's 3 of them, so we've got, what is that, 18,000 sank in those servers. We could get new servers of similar specification for less money, for about $3,000 a piece. So I'm just going to put in here, there are 3 of them. They originally cost $6,000 each, right? And the operational cost of $600 per year each just in electricity. And what Philip was showing me was that the new servers, if we wanted to get 3 of them, these cost around $3,000. So they cost about half as much as they did before, right? Just because the cost of memory comes down, the cost of storage comes down, all that comes down over time, all right? But he showed me where the new ones had a much lower power draw. In fact, it was so low that their operational cost, he was showing me, was right around something like $90 per year each. So the newer power supplies were far more efficient. They drew a much lower wattage. The newer CPUs required a much lower wattage. So what he was showing me was that for each of these servers we replace, you're actually saving $510 per year. So that equals a $510 savings per year for each server. All right. And his argument was, if the server costs $3,000 and you save $510 a year, doesn't it make sense to go ahead and replace them? Get some new servers in there and replace it. Well, here's where we do our cost-benefit analysis, right? We look at the cost versus the benefit. The cost would be $3,000 per server, and there's 3 of them. So our cost-benefit analysis, right? Our cost would actually be $9,000. So our cost, $9,000 for new equipment. All right. Our benefit would be a $510 savings per year, but there's 3 of them, right? So it would actually be a $1,530 savings in electricity per year. All right. Electricity, there we go. All right. So I'm saving about $1,500 per year, right? Well, that sounds like a great idea. I can save $1,500 per year. I should do it, right? Well, here's the thing. Let's look at the cost to benefit. The cost is $9,000 to be able to save $1,500. So when does that pay for itself? When does it start to benefit us, right? Well, we have to work that out. $9,000 divided by $1,500, right? Yeah, I'm just going to round it because 30 bucks is 30 bucks. That equals, what is it, 4? Oh, no, it's 6, right?
Yeah, just about 6.
So it's 6. It would take 6 years for these servers to pay for themselves and start to earn us money back, okay? So for the first 6 years, that power savings is just compensating us for the cost of the initial servers. We don't actually make that money back. Now, in some worlds, that's perfectly fine. But in the IT world, if I buy servers today, am I going to be running them 6 years from now?
Probably not.
No, servers don't normally make it 3 years, better yet 5. And so, Am I going to run these 6 years? No. So they won't have time to pay for themselves by the time they die out, by the time I'm ready to replace them. So the cost to benefit analysis here shows that this should not be the sole factor I do the upgrade. Okay, I say it that way because there might be other factors.
Right.
Our old servers, they are just that. They're old, right? They're not under warranty anymore. If I have a motherboard fail,
Yeah, we're up.
yeah, I got to go on eBay and find one or something like that. But if I get new servers, they'll come with a 3-year warranty. So they'll be under warranty. If something goes wrong, I've got that. So there may be other benefits that I need to be aware of. But just looking at raw cost here, this looks like a pretty easy decision. I shouldn't be motivated to replace the servers unless I just feel like it, right? This is not a reason, all right? So that's what a cost-benefit analysis is. We just need to take a honest-to-goodness look, quantify our numbers, figure out, does it make mathematical sense to do it, right? And you see many projects across the world that don't take the time to do a simple cost-benefit analysis, and they end up going kind of crazy. And I said biomass earlier, which was kind of an inside joke. The city of Gainesville, where we are, we approved a biomass plant to be built years ago, right? It was approved like 10 years ago. It just went into operation about 2 years ago. And it's turned out to be just a outright debacle that the cost of operating the plant has far exceeded any benefit on it, and it's turned out to just be a mess. And they're actually having to chop down trees to power it, which is completely against the environmental idea of it. So it is a mess. So that's why I threw that one out there. But you see it in any project, right? You're building a new house, and you decide you want to put solar panels on it. Okay, the solar panels cost money. Do they offset? How long does it take for them to pay themselves off? Well, with solar panels, it's different than servers. 6 years, that's too long for servers. But let's say this same thing played out a different way. Let's say that it was solar panels that cost $9,000 and they saved us $1,500 a year, right? It would take 6 years for those solar panels to pay themselves off. But how long am I going to live in that house? I might live in the house for 30 years. A house could stay standing. There's plenty of houses, well, not in Gainesville, but in other cities that are 100 years old. For our European viewers, might be hundreds of years old. And so in those scenarios, will the solar panels pay themselves off? Absolutely. And is it worth it to do it? Absolutely, right? So it definitely depends on what you're doing, the other kind of circumstances that surround it. So that is a cost to benefit analysis, very common thing, and it should really be done with just about any expenditure. All right. Other things, where is there? All right, cost of quality, right? I mentioned cost of quality in another episode. Cost of quality, it actually takes two forms. We have really two different concepts when it comes to quality. Let me, this was basically like a cost benefit analysis. All right. So when it comes to cost of quality normally represents itself in one of two ways. So cost of quality, it's going to represent itself as either quality control or quality assurance. All right. So quality assurance is the first one, quality control is the second. And we're going to see more of these when we get into execution. But quality assurance, that's preventative measures, and I'm writing this. Ronnie, you already have notes for this, don't you?
Yep.
I am spinning my wheels, aren't I?
Right there, yep.
Where? Right here, cost of quality. Okay, so we have quality assurance and we have quality control. And, well, actually, you do all that, but let me just write these out and then we'll come back to this. Yeah, because you've got important stuff there, but not exactly what I wanted to say. So, so quality of assurance, that is preventing quality issues before they occur, okay? Quality control is correcting quality issues after they occur. They're really the same concept. It's just one is proactive, one is reactive. They both have a cost, they both have a benefit, and we have to determine whether or not it's worthwhile to do either one, okay? So, for example, if you're an automotive company, if you're manufacturing, what car were we manufacturing?
The Ford Focus.
That's it, the 2016 Ford Focus. So you are Ford and you're going to be manufacturing this vehicle. You've got a choice. One, you can improve your assembly line to produce a better car. A better car will have less failures. Less failures means less warranty work. So you save money on the back end by not having to do warranty work, but on the front end, you're paying extra to make your assembly line better. All right, that is quality assurance. Quality control is where we say, you know what, let's just make the car and send it out. And if anything's broken, people will bring it back for warranty work and we'll fix it then, right? So we save money on the front end by not having to improve our processes, but we spend money on the back end having to fix the problems as they occur, if they occur, all right? Now, it's not normally a one-size-fits-all. Normally we do both. We find out certain things that we can do for quality assurance ahead of time, and then other things we evaluate and say it's a low enough risk that we pushed off for quality control later. And we're seeing that now with, what is it, like the ignition systems? Have you read about that, Ronnie? Mm-hmm. Something, and I don't understand this because I don't have an automotive mind, but there's some kind of piece in the ignition system of a particular vehicle that it should have been longer. And longer than what it was measurement-wise. And something happened in the manufacturing process where it was manufactured shorter than it should have been. So they had a choice. Either recall all the vehicles and fix it, or just let it go. Let it go, and as problems happened, they would fix them. And that's the choice they made, is they said, you know what? The cost of fixing them as problems occur will be less than the cost of us going and doing the repair right now, so we'll just wait. And that was fine until somebody died. And when somebody dies, then it becomes a big deal. And so then they went out and now they're repairing the vehicles. The automotive industry is a little cynical in that aspect. But now they're doing quality assurance. They're saying, okay, for every vehicle manufactured from now on, we're going to make sure that part is long enough, right? So it's really a combination of the two that's going to suit your environment. The trick is just figuring out whether it's worth the money to fix it ahead of time or fix it after the fact. Fixing it after the fact not only has a monetary price, but it also has a public image, public relations price. You know, if you have a giant recall, that's going to hurt sales of your vehicle. That's a big deal. So when we're talking about cost of quality, those are the costs that we're evaluating. The cost of fixing things ahead of time to ensure problems don't occur, or the cost of just letting it ride and fixing the problems as they do occur. All right. So let's take that idea, and I'm just going to stick that here in the notes, and you went straight from the pin box, so I'm just going to add right above it there. Okay, so when we talk about cost of quality, you see it worded a few different ways, and so here we've got like cost of conformance. What's it going to cost us during the project to prevent that failure from occurring? And that's what we would call quality assurance, or QA, all right? And then you'll see cost of non-conformance. That is, if we let the problem happen and we go and resolve it after the fact, that would be quality control, all right? And we'll see those two concepts more in the execution phase, or really monitoring, controlling. But you'll see here under cost of conformance, you've got the prevention cost. So whatever it does to improve your processes. Maybe you have to buy some new machinery. Maybe you have to add an extra inspector on the inspector line. Maybe things take a little longer to manufacture. So documentation, equipment, time to do it right. All of these things have real cost associated with them, and we need to figure out whether it's worth it. Same thing with non-conformance, right? Rework, where you have to go and fix something. Scrap. Maybe you have to throw it out altogether, right? If you're McDonald's and you're manufacturing hamburgers for your customer and you mess up an order and they bring it back like, you ruined my order, what do? You can't just fix it. You have to throw it out and make an all-new hamburger. Well, a hamburger probably costs them pennies on the dollar, but if you're talking about an entire vehicle, like Lemon Law or whatever, then that gets expensive. So what happens there? Liabilities, that's the big one. Liabilities, if the failure is shown to be due to negligence on your part, the legal cost can be through the roof. If somebody dies as a result of that failure to meet spec, that's a big deal, and it's going to cost a lot. And how can you put a price on a human life? If you're dealing with something that is, somebody's life depends on it, you take the time to spend that money ahead of time to get that product designed right. All right, and then warranty work, I already talked about it, and then lost business, right? That public relations side if you make a bad product, one that has a lot of returns, it's going to hurt your overall image. And we saw that with Packard Bell, right?
Yeah.
Packard Bell was a computer company here in the US. I think they still sell under the Packard Bell name in Europe, so some of you guys might be familiar with them. But for a while, they were the leading brand of computers. Everybody had a Packard Bell. And then what they did is, to save money, they started using refurbished parts in their computers. And it created a higher failure rate. And so Packard Bells became known as Packard Hells, that if you got one, you knew it was going to have to go in for warranty repair every couple of months. And the quality level went down, and it became such a product that you just didn't want it. So it hurt them, and now they don't do business under that name in the US anymore. The brand has been ruined here in the US. All right, so those are some of the things that we've got as far as quality control now and quality assurance. Now, how do we actually plan for a lot of this stuff? Well, we've got 7 basic quality tools that we're going to take a look at, but we don't have enough time left in this segment to hit them. So let's do this. Let's stop and take a break. And when we get back, we're going to take a look at those 7 tools, what they do, how they work, and get an idea of how we can use them as we start to plan quality in our environment. All right, so stay tuned. We'll be back after this. All right, welcome back, everybody. So now we're going to take a look at these, they call them in the PMBOK, the 7 tools of quality management. And there's way more than that, but there's 7 that they specifically call out. And they're easy things that we can put to use to help us make sure that we're, well, providing quality in our project, right? There is a awesome diagram in the PMBOK. I'm just going to pull it up here. So this is, in the PMBOK is page 239 if you've got one. And they basically lay out the 7 tools as pictures. I like pictures because that's really what all these are. And if you're trying to deal with quality in your project, either beforehand or afterwards, these are the tools that we're going to use. So let's look at each one. The first one is what's called a cause and effect diagram. Now, there's a few different names for this. You'll hear it called a fishbone diagram or an Ishikawa chart. There's a few different names that are out there. But at the end of the day, it's a cause and effect. And what it's doing, I don't know, how far in can I zoom in on this thing? It's still pretty clear, even zoomed in like that. What you do is basically you set up what it is you're trying to achieve. Okay, so what am I trying to achieve? Well, here it says awake at 2 a.m. daily and strong odor. So that's I don't know that I've ever actually read this.
Root cause analysis of sleeping problems.
Okay, so basically they've got somebody who's got a problem, right? So they're waking up at 2 a.m. every day, and at 2 a.m. they detect a strong odor, and they don't know why. So now we start to try and identify the potential causes. What could be causing this person to wake up at 2 a.m. and to smell a strong odor? So we've detected a flaw in our process or our project or whatever. Now we're trying to identify what caused the flaw so that we can then go and take corrective actions. And there might be more than one thing that contributes to it, right? So as we start to look at this, we see there might be issues with our materials, our methods, our people, or our environment. The 4 categories they've divided up. And you can do as many categories as you want, but these are pretty standard. And so looking at these, if we break that down even further, we'll see, trying to identify the root cause of that problem. So materials. Maybe there were pesticides, cleaners, in bathroom materials that were used. Maybe the dirty sheets, all these things can be contributing to the odor. Not necessarily contributing to waking up at 2 a.m. so much, right? Versus other things that might be disturbing somebody. Here they've got body odor with people. This is a really pleasant diagram. You'd think they'd come up with something else. So these are all just trying to identify that. In the environment, maybe there's a skunk outside, right? And so that's contributing to this odor. Maybe the air conditioning. Maybe the air conditioning is turning on. Maybe it's generating a smell. Maybe garbage cans are too close to the AC, so garbage smell is being brought in. All of these are potential causes. Now, which one is the true cause? Well, there's likelihoods, probabilities. The odds of there being a skunk outside might be pretty low. Here in the U.S., we have skunks. In other countries, maybe you don't. So you have to kind of evaluate that. But each of these are possibilities, right? And that's really the point of a fishbone or Ishikawa diagram, is just to basically break down what are the possible causes. Let's do some brainstorming, come up with things. And then as we look at it afterwards, we say, what can we do to curb these? Because each of these are really a type of risk.
Right.
You know, there's a risk that there could be a skunk outside, but there might not be, right? It's not a guarantee. So we need to evaluate that and determine whether there's any mitigation tactics that we should follow, right? That is a cause and effect diagram, all right? The next one is a flow chart. With a flow chart, when we start to break down one of our processes, we look at all the various activities that are happening and the things that could go wrong, right? And anywhere there's a spot where something could go wrong, we plan what we'll do as a result. And so they show here, this is a project happening, right? So we get a project requested, we get a plan. Is there artwork requested? And then if there is, we work on it. And then is the artwork approved? If yes, we continue on. If no, we go back and we generate new artwork and we try and get it approved. And we might have to cycle through here a few times to ensure that we get artwork that meets the needs of our customer. If we don't, if we just move on, we might reach the very end of the project and they say, you know, that artwork, it stinks. It's not what I want. And then we have to go back again. So these are the typical type of issues that we have. By making a flow chart like this, we can kind of map it out, and anywhere we have a decision point, it's normally represented as a decision diamond, that we basically evaluate our possible outcomes from there. And you'll see they've got it down here. So vendors make the proofs. Does the development or package or whatever, does it get approval? If it does, we move on. If not, we go back to more proofs. Same thing with, does it meet QA review, right? Quality assurance before we send it to our customer versus quality control, which is after it gets to our customer. So flowcharts are pretty handy with that for mapping out where we need to have those decision points. Checklists, or check sheets, they call them. Checklists are like the #1 tool of quality control. And we're going to see in the monitoring and controlling processes where we actually have to create these checklists that you've got a set of requirements that say, I need to meet these requirements for the project to be successful. So a check sheet or a checklist is really just saying, did I meet these requirements? Yes or no, right? And we go through and we check them off. Attribute 1, do we meet it? Yes. Attribute 2, do we meet it? Yes. Attribute 3, do we meet it? No. All right, we got a problem. We're not meeting quality, right? And then frequency, how often do we check, right? Is this something that we're checking every day, every hour? If we're manufacturing, I think I used blue jeans in an episode the other day. If we're manufacturing thousands of blue jeans per day, I can't run every single pair through a quality check. So maybe I'm sampling 1 out of every 100, and I'm checking, running it against this checklist to look for tolerances, right? It's a very common thing. All right, we've got Pareto diagrams. Now, Pareto diagrams are one of those that look really complex, but are actually really simple. Let's say that I am manufacturing 1,000 pairs of blue jeans per hour, and I've got a defect rate, right? And my defect rate is 20%, and I want to get that defect rate down. I don't want it to go out to the customer and have the customer have to return 20% of my product. That means 1 in 5 customers would be doing a return. That's going to hurt my image. So what I do is I look at the defects. So out of a batch of 1,000, I collect the 20% that are defective. And we categorize where their defect is coming from. So maybe in a certain percentage, I see that the zipper won't stay up. For some reason, the zipper keeps falling. In another percentage, the button isn't properly attached. In another one, maybe the button hole is not cut out. Something happens with our machine where it doesn't cut out the hole, and so on. We break down all the reasons for a defect, because the defect can come from more than one area. All right. So we break down all the reasons, and then we sort them by which one happens the most. And we look at the one that happens the most, this guy right here. We total up all the incidents, and if I grab 20% of my 1,000 pairs of jeans, then I should have 200 defects, and so these should add up to 200. That's what this line is here. It's just making sure that our full number adds up to 200. If it doesn't add up to 200, then I must have missed some defects. I need to go and find those out. Even if there's only one pair that suffered from a particular defect, I still need to document it. But when it comes to finding solutions, I want to solve the biggest culprit first. If I can solve this one right here and it amounts to 50% of my defects, then I just saved 100 pairs of jeans. all these other guys combined might only be 100 pairs of jeans themselves. So it makes sense to focus in on this one. I say, all right, for some reason, the zippers are not staying up in 100 out of 1,000 pairs of jeans that I manufacture. We need to replace that zipper. We need to change that design, or you use a different contractor or something like that. Just by changing that one component, I now I increase my yield by 10%. That's a big gain. That's worth it, right? To save 10% of defects. Then I can say, all right, what's the cost to benefit, analysis on that? How much does it cost to use a different zipper? If it costs the same, it's a no-brainer, do it. If it cost a little more though, what did it cost us to lose those 10%, right? Well, if the cost of replacing the zipper is higher than the cost of the 10%, then we just take that 10% that have a bad zipper and we throw them into the defect rack, right? And they make it over to, a lot of times they'll sell them at outlets or whatever. These are defective goods and off they go. So maybe we do that. It makes sense for us just not to even bother and fix it, because 80% of our jeans are fine, and we can sell those at full price and we recoup our loss, right? That's what a Pareto diagram helps you to do. You're just doing, this is a histogram, a bar chart, that is mapping the amount of incidences of a particular defect. So this is one defect, this is one defect, this is a different one, this is a different one, and so on. And then a line graph that's showing the total amount of defects to make sure that we add up to 100% of our defects. All right, so Pareto diagrams, they look complex, but they're really not very hard at all. All right, histograms. Histograms are another combination where we've got a bar chart. Really, that's the histogram, is the bar chart. They've done like a trend analysis here, and that's not truly part of the histogram. You can have that if you want, but the bar chart is the histogram. And again, we're just ranking incidences of typically a particular defect, and this might be over time that we have that defect. It depends on how you want to map it. I'll give you an example. I have a friend who, it's an odd business, but he makes his living manufacturing cowboy hats. He hand makes leather cowboy hats. Apparently there is a market for this, and he sells them for ridiculous amounts of money. I've never worn a cowboy hat, nor do I ever intend to, but this is what he does. And he hand makes them. He makes them himself by hand, which is impressive. And when he does it, he uses wooden molds. So if he's going to make a size 7 1/4 hat, he's got a wooden mold for size 7 1/4. And if it's going to be 7 3/4, he's got a size 7 3/4 mold for that. So he's got these little wooden, they're not heads because they're shaped weird, because he actually shapes the leather around that, so it's more shaped like what a cowboy hat would be. So anyway, he's got these molds that he uses. Well, the problem is they're wood. And after he makes a few hundred hats on the mold, the leather starts to wear the wood down. And that 7 3/4 hat all of a sudden becomes a 7 1/2. And then as he works on it even longer, that 7 1/2 becomes a 7 1/4, right? The mold gets smaller and smaller and smaller as it wears down. You see this with blue jeans. Well, we'll stick with the blue jean example. If you go to the store and you grab 3 pairs of size 32 jeans, 32 waist, some of them might be 32, some might be 33, some might be 31. There is an acceptable deviation from that measurement that they allow to still sell it out there. But that's why 2 identical measured jeans might fit differently, because of those tolerances at the factory. So what Patrick had to do with his hats is, as he manufactured them, at the end of each day he had to measure the molds. And there was a certain deviation he would allow, where it might not be exactly 7 1/4. It might be 7 3/8, right? Just a little bit more than 7 1/4. So if that was the case, he'd still sell it as a 7 1/4. It was okay, right? But once it deviated far enough, he would then relabel that mold to be the different size, and now it would work as that different size. So with a histogram like this, we can start to chart that how long does it take for that mold to wear down and to start manufacturing a different size. And so, on day 1, it was manufacturing hats at this size. On day 2, here's our deviation as we start to creep up. And so then we replace the mold. We move it, we swap it with something else. So you might have one that just goes continually up. You might have one that goes like this, that goes up and then down based on what it is that we're working on. I might say over the course of a day, it manufactured this many hats that were at these 2 sizes. But these other sizes were outliers, right? At the beginning of the day when the mold was nice and cool, it was manufacturing down at this size. And as it warmed up, it started to defect into higher sizes. And so we may map that out too. But a histogram is a simple tool. It's just a bar chart that maps that out. Now, I mentioned tolerances, okay? In manufacturing, you've got tolerances. You have what are called control limits. And basically what you say is when you manufacture something, you know that it's not always going to be exactly the same. It's very difficult to reproduce something exactly. And so what you're normally going to have is a target, right? Here's our average, our target that we're trying to hit. And then as you manufacture, some things might hit the target perfectly. Some might go over, some might go under. You know, they get close, but not perfect. So I want those pairs of jeans to have a 32-inch waistline. That's what I want, a 32, okay? But I might get some that are a 33 or a 31. You know, as long as they're close, it's good enough. I can sell it that way, right? It's meeting my tolerance. So if we have a tolerance like that, it's important that we establish it early on in our quality management plan. And we specify what's called a upper control limit and a lower control limit, a UCL and an LCL. The upper control limit is the most in a positive direction we can deviate from the norm and still sell the product as not being defective. Once you cross that limit, now you're defective, right? And your lower control limit, the same thing. The farthest negatively you can deviate from the norm without being considered a defect, right? And in most manufacturing, you do have an acceptable window, a plus or minus window that you can fall into and still be an acceptable product. If this is engineering, you might have two parts that fit together, and they fit together fine as long as they're within a few millimeters of measurement of each other. But if they get more than 4 millimeters different, then it's too far apart, and they're not going to fit together right. They're going to have uneven wear and cause breakage. So in those cases, we need to measure that out. This is going to vary from project to project, right? Whatever it is that you're dealing with, you'll have these acceptable limits. So here they're talking about call wait times. So they have a call center, and if somebody calls in, they only want them to wait on average 15 seconds. So if somebody calls in, they want that phone to be answered within 15 seconds. And they set an upper limit of, what do you think that is, Ronnie, like 23 seconds or something?
Yeah.
Saying that if it takes as long as 23 seconds, we're okay. If it takes as little as 7 seconds, we're okay. But if we deviate above that, if it takes too long to answer the phone, we have a problem, right? If we answer the phone too fast, we have a problem. That might sound crazy, but then you know maybe that makes your company sound desperate. You answer the phone right away, so you know that's just not long enough. So we set these limits of what we consider acceptable, and we monitor our trend. You might notice here that they didn't do the trend, but if you look at this, notice how we start kind of below here, and we're really below, and then we start kind of creeping up. And now we're not so much below anymore. And towards the end of this, see how we're not very far below at all? There's a general trend here of going up. So our average wait call, if we were to map that trend, is slowly creeping up, meaning our wait times are starting to increase. Now, this is being done over, they just show 20 samples. I don't know what that is, right? Maybe this is 20 days. So over 20 days, I've got a general trend of increasing call wait times. So if I map this out, how many days is it going to be before this general trend hits my upper control limit, right? So we can use this to kind of predict the future. If this trend stays the same, 2 years from now, I'm going to hit my upper control limit, okay? And so I can make plans for that. I can say, you know what, 2 years from now, I'm going to need to add some more phone reps so that we can get that call wait time down, right? That's what this stuff is all about, is kind of planning for that eventuality. All right, and then the last of our 7 tools, the scatter diagrams. Scatter diagrams are where I do my statistical samples, right? If I'm manufacturing 1,000 pairs of jeans, I don't want to go out and look at every single pair. So maybe I grab every 10th pair or every 100th pair, and I throw it on a diagram where I map, you know, here they're doing temperature versus pounds per square inch, and so we map, you know, what that is. So here, what would you measure temperature and PSI for? An engine, maybe? So,
could be
like compression on an engine, or
yeah,
I don't know, whatever it is. So we would measure these two values and chart it out. And what you're looking for is, again, that trend to see where you are on average, and then if you have deviation. I see this big deviator down here, this outlier. What's going on there? What caused that, right? Is there a flaw in my manufacturing process that led to these, or is that just something that happened, right? An outlier that we can disregard. So scatter diagrams help us to plot that and see when we've got deviations. With a scatter diagram, the goal is to have all of your dots be as close together as possible. A perfectly working system should only have one point. Everybody falls at the same point, but it's never perfect, right? So you'll see it a little more like this, where it kind of flowers out. But if you've got it all over the place, that means a very inconsistent process and something we need to reevaluate. So those are our 7 tools available for quality control. They're all pretty common sense. They're pretty powerful. The challenging part in the exam is just remembering the names, because some of them are strange. The Pareto diagram, right? You might not be familiar with that one. And then the cause and effect diagram, because it's got 3 names, right? Also a fishbone, also an Ishikawa, and I think, Ronnie, you had all those in the notes, right? Let me bring that up. So yeah, cause and effect, also known as fishbone, also known as Ishikawa. So just be familiar with those names. They may turn up on the exam. All right. Some of the other things that we might see, those 7 tools, that's the big deal. We also have benchmarking. Benchmarking is where, maybe we don't know exactly how accurate our stuff should be. So we come up with a benchmark, a goal that we want to hit. And it might be something that we set internally, or we might reach out to our competitors or other people in our industry and say, we're manufacturing 1,000 pairs of jeans, and here's the defect rate we're trying to get to. I wonder what Levi's hits, or what Lee, or some other competitor, what defect rate do they have? And then we kind of work towards that. We use that as our benchmark. We compare that against what they're doing to see if we're being competitive. It might be an internal benchmark. Last month, here's what my defect rate was. So this month, I want my defect rate to be the same or better. So last month's defect rate becomes this month's benchmark, right? So that's kind of a goal that we work towards. Another tool or technique we have is design of experiments. This is a tough one, right? If we are manufacturing blue jeans, well, I'm a project manager. I have project management skills. Do I have manufacture blue jean skills? No, I couldn't do it. I don't even know how to work a sewing machine. If you gave me a pair of blue jeans, am I capable of judging whether or not the blue jeans are up to quality? No, I don't really know what quality comes down to if you just stick them in my hands and tell me to look at it, right? So what we need is to come up with tests to evaluate the quality of our product. So we're typically going to bring in a subject matter expert, and they're going to do design of experiments, and that just means they're going to create the tests that we use. And it could be as simple as a checklist. You look at the jeans, you do a checklist, right? You ever buy a new pair of jeans, you stick your hand in your pocket and you pull out a sticker that says inspected by 47, right? That means that there was a quality assurance person at the factory whose ID number is 47, who had a checklist that looked at your pair of jeans and said that your pair of jeans met their checklist requirements. That's usually all the experimentation we get, all right? It might be a lot more sophisticated. There is I did a little bit of work for a road paving company. And when they would pave a road, I don't think much about it. I'm like, yeah, they just put down asphalt, draw some lines on it, they're done. Easiest job in the world, right? Well, when they manufacture that asphalt, they have a number of chemical experiments they perform on it to make sure that it meets certain consistency levels, that the components are mixed in the right quantities, and that it will withstand the test of time. And so every batch of asphalt that they manufacture has to meet these tests, and they have a chemist on staff that actually does those tests. Very sophisticated, way more sophisticated than I thought it was. And then after they lay it, they have a radioactive depth measurement tool they go through, and they can measure the density and the depth of the asphalt at any point. And so they do these measurements every so many feet to evaluate how dense that asphalt is. They're doing that because if they don't, the road is going to wear down early, and sinkholes are going to occur. And so if that happens, they're going to get back out and fix them. And it's tough to shut down a road to fix them. And it's even more tough to have a city that has the funding to repair the roads, as we see here in Gainesville. So it's like pothole city out there. So So that's design of experiments. Somebody's got to create these tests, and we create the tests in the planning phase, but we don't use them, right? We use them in the monitoring and controlling phase. Statistical sampling I've already talked about a few times now, and that is you can't test everything. Well, you can if you have enough time and resources, but for most of us, we grab a sample that is big enough to be statistically significant, yeah. And if you get too small of a sampling pool, then it's not going to be significant. The numbers aren't going to be realistic. So you got to get enough that is, and it just comes down to what your error rate, your acceptable error rate is. But you collect some samples, you do your testing based on that, and then you extrapolate that out. And you say, all right, if 1 out of 100 are defective, then 100 out of 1,000 are probably defective, or 1,000 out of 10,000 are probably defective. So you can kind of use that to evaluate your overall loss. And then after that, it's kind of left up to us, right? Additional planning tools or quality planning tools. There are a number of other things that are out there. So we'll see, things like brainstorming, force field analysis, right? You kind of see what forces are acting against your tolerances, and whether you've got things in place to mitigate that, or whether you need to take action. Nominal group technique, I know we've already talked about. As well as quality management and control tools. Any of the various things that we've seen in our other processes, we've got them here too that we can use as we do our quality planning. And then there's meetings, right? Endless meetings as we figure out our quality needs there. Okay. Once all this is done, once we've leveraged these tools, we now know what we need to do to get quality in place. Now we do it, right? Our output for this process is going to be our quality management plan, so how we're going to handle quality. And if we already had one, then it might just be updates to that plan, so we'll see project document updates. But if we don't, we draft it here and we keep it generic enough so that we can reuse it in other projects. All right. We also see things like a process improvement plan. So it might not be our product that's at fault. It might be the way that we create it. Yeah, the process. So we need to go and evaluate that, and if we find improvements that we can make, then we create a plan that says how we're going to improve it, or we create a plan that says how we will evaluate to determine if we can improve it. We also have our quality metrics and quality checklists. So the metrics, those are all the numbers we're going to measure against. What is the acceptable deviation for our product or whatever it is that we're doing? And what are the metrics we're going to measure, the checklists we're going to check against, right? We're creating all of those here in the planning phase. So when we're done, we have a collection of documents that are ready to rock. I do have a template or two I wanted to show you guys. So when we talk about like our process improvement plan, right? Let me bring that up. So we basically describe the process. We describe the starting point, the ending point, the inputs and outputs of that process, as far as its boundaries, and we basically just come up with ways that we can improve it. So what our metrics are and our control limits as they stand right now, what we want to improve, and what we're proposing to improve them, right? How is our improvement approach? Are we evaluating it every couple of weeks, every couple of months to see if there's something we can do? Are we evaluating new technologies to see if there's improvements, new equipment, what it is that we're going to be looking to do for that? And then if you want, you can attach a flow chart. So this is what a process improvement plan looks like. It's documenting not only how the process is right now, but what we're doing to evaluate those improvements down the road. All right, and then there's our quality metrics, where we document what it is we're monitoring, the item, right? And then what the metric is. And remember, the metric could be money or time, but it's most commonly requirements, right? Different features that we expected to have, and what is the metric for it, and the measurement method. So if it's manufacturing the blue jeans and you have a waist size that you're monitoring, our metric is, I want to be plus or minus 1 inch from the advertised waist size. So if I say it's a 32, it could be as low as a 31 or as high as a 33, and we'll still call it a 32. All right. The measurement method, take a tape measure and measure the inseam or the waistline of that pair of jeans, right? So we just designate how we're going to measure that and what's acceptable. What's that metric? And then our quality management plan that we output, very similar to the process improvement plan, because we're specifying what is our quality planning approach? How do we plan for it? What are we going to do to get ready for quality? What is our quality assurance approach? How do we determine what we do ahead of time versus we put off to deal with later. Quality control. How do we determine what to deal with later as opposed to dealing with ahead of time, right? So this is not saying exactly what we're going to do because this is our plan, right? But how we determine what we're going to be doing is quality assurance and quality control. Same thing with quality improvement. If we see our quality is not at the level we want, what are the steps we can take to improve upon it? These are all documents that we should have nice generic ones for our company to reuse, but then we create specific ones that deal with our project, what it is that we're going to be doing within the boundaries of this project specifically to improve those areas. All right, and remember, I'll be posting all these templates with the episode, so by the time you guys are seeing this recorded, they'll be right there on the site, probably in the course resources.
Yeah.
So. All right, so that pretty much wraps up quality. Ronnie, I'm trying to think if there's anything else on quality we need to tack on to. I do apologize if any of you guys out there are, if you have a master's in quality management, there is a lot more. But as far as the PMI is concerned, as far as the exam is concerned, those are the main areas. We are going to talk a little bit more about process improvement when we get into execution. Yeah. We do have to talk about Deming and a couple of the other people that are big names in the quality world.
Yep.
But for right now, as far as planning is concerned, those are our general things.
That's good.
All right, well, let's stop here and take a break. We've got a lot more to get through in this episode. We're going to start taking a look at human resources and communications also. So stay tuned, and we'll be back after this. All right, welcome back, everybody. So now that we've wrapped up quality, we're ready to move into our next knowledge area, which is the, human resources, right? We got to plan our human resource management plan and stuff. So
Yep.
I know I talked about in cost how we had to worry about things like materials, right? And you have to worry about personnel, labor cost, and so on as we evaluate how much each activity in our project is going to cost. Well, a part of that was a little uncertain because I said it's hard to figure out labor when you don't know who your people are going to be. So in the early planning stages of our project, we probably have a lot of placeholder people or silhouettes, ghosts, whatever you want to call them. So I might have web developer 1, web developer 2, web developer 3. Well, at some point, I've got to get actual people to fill those holes, and those people will have different salary requirements and needs. So we have the human resources management knowledge area, which centers around how we get those people, how we get them attached to the project, and how we handle them, because people unfortunately do need to be handled. So let me just bring up my process groups chart here. And so we just wrapped up quality management, and now we're moving into human resource management. Now, you'll notice this is not a very big area, and that's because most organizations have a human resources team, or most environments have a PMO, a project management office, which is handling that assignment of human resources. So we may not need this much at all. Now, you are going to need develop a project team, manage a project team. You're always going to need those, but doing the human resource management plan and acquiring the project team, those two might actually be taken care of for us by other entities in our company. All right, but let's say they aren't. If they aren't, well, we need to get that human resource management plan in place, and so we've got a process for that, and we'll take a look at what's here. First off, if we already have a plan, it'll be in our project management plan. That'll be an input for us, so we go and we get it. All right. If we don't, it's up to us to create our own. So we take a look at some of the various other things we have. The main thing being activity resource requirements. I need to look at the activities that we charted out before, and I need to figure out what they need. I need web developer 1, web developer 2, web developer 3. All right, I got to put some people in those places. So we go and gather all that together. We may have enterprise environmental factors. Now, in the past, I've said these are like standards and regulations. Well, when it comes to human resources, this is super important. Many countries, the U.S. included, have labor limitations. A certain amount of hours people are allowed to work. You might have guidelines within your own company that say people can't work more than 40 hours before they go into overtime. They get Saturday and Sunday off or closed, or whatever it is that's in your company. That's part of your enterprise environmental factors. And then organizational process assets, that's going to include any templates and historical data of other projects that have dealt with this, as well as, in a lot of cases, the employee documentation. So how do you know who works for your company, who you have available, because you might have to contract out to get some people. You might not have them internally. All right, so once we've got that data together, we're ready to work with it. There's not too much to go on here, right? Hopefully, we have organizational charts and position descriptions. If I know I need a web developer, I should have a company directory where I can identify who my web developers are. And I should be able to look at that chart to figure out who their boss is. So I can go to their boss and I can say, hey, I'm Don, I'm the project manager for our new online mortgage payment project. And as part of this, I'm going to need 2 web developers for approximately 60 hours of work. Do you have somebody available? Can I get them? Can I bring them in and get them as part of the project? And if they say yes, you're coordinating with that functional manager to get and secure that personnel. If they say no, then you say, okay, well, that's cool. I'm going to have to contract them then. So I'm going to have to bring in some contractors and bring them in place to do this work. So we're establishing that. We're trying to figure out what we need. The organization charts are what are going to help with that. Now remember, what was it, Ronnie? Like episode 2, where we did the functional organization matrices and stuff. Right. You might have a projectized company, you might have a functional company, you might have a matrix company. So as a project manager, you might already have the authority to get these people. You might not. You might have to ask a functional manager. That's where those organizational charts come in handy also. All right, networking. Networking is getting to know people, right? Hobnobbing, bumping elbows at community events. If you need some web developers, how do you find them? Well, it might be that you're a part of a technical group or something like that where you've met web developers that are out there in the community. So if you're looking for a contractor, you're not just trying to guess, you have people that you can go to. We actually just did this for IT Pro TV not too long ago. We needed help with some of our marketing. We are terrible marketers. We don't send out huge amounts of advertisements and things. So we said we really need somebody. And instead of going out and trying to find them on our own, we went to a conference. We went to this conference where there were tons of marketers, and so we could shake their hands, talk to them, and get a good feel of who would be right for us. And so, that's something that's very handy. That's all a part of networking.
Right.
And you don't just do networking externally, you do networking internally too. If you're relying on resources coming from a functional manager, you need to know them. Right. You need to, go sit down, have lunch with them, talk to them. You get a good idea of who they are, how they work, and what their requirements are. Organizational theory is another one. Now, this is a big one, and if we kind of dive in, Ronnie did good notes on this stuff. Organizational theory, it's a big deal. So we're basically saying that there are a number of different ways that we can organize our companies, like the functional and projectized and all that. And so we need to make sure that we've got a good grasp of how our company is organized. And then when we bring in employees into our project, we're creating like a microcosm, a small company. And so we have a different organizational structure inside of the project than we do in our company ourselves, and we have to be aware of that. And I was leading into the Racky diagram, but I see that you've already got that up here, so I skipped over it. Yep. So I did talk about the matrix-based and hierarchical stuff, so that's good. But one other thing that we might be doing as we develop this is what's called a RACI or Racky diagram, which is responsible, accountable, consult, and inform. It's a chart of people, and we designate what role they're performing inside of our organization. And I've got a template for this. Let me see if I've got that handy here. I think I had it open this morning, which was, here we go, responsibility assignment. So this is what a Racky diagram looks like. Basically, you have your work packages. These are from your work breakdown structure, your WBS. So here's stuff that needs to get done. And then up here is a list of people that can do it, person 1 through person 4 and so on. And what you do is you designate what role that person has in that particular work package. And so you'll flag them as, and you'll see the little legend down here at the bottom, R is responsible. That means if person 1 has an R for work package 1, that down here I can see that they are responsible for that work package. They've got to do it. They're the ones who have to get it done. If it was an A, they're accountable. That means they're not necessarily the one doing the work, but if it doesn't get done, it's their fault. So I might need web developers, but I don't have any. So I go to the CIO, the Chief Information Officer, and I request from her, I say, hey, can you give us some web developers? And she says, sure, I've got them. Flag me as the one who's accountable. I'll make sure my web developers get it done. All right, and so off you go. You don't even know who the web developers are because she's the one who's acting as that intermediary. She takes care of it. She is accountable. And then consult. They're not the ones who are responsible or accountable. They're not actually doing the work or even involved in it. But I may need to consult with them about decisions that are being made as a part of it. These might be subject matter experts. These might be people that are high up in the chain but aren't the ones who actually do the work, and so they need to be consulted as we make decisions. Your project sponsors almost always consult. And then we have inform. They're not involved at all in this particular activity, but we need to inform them of the status. And so if you have a real hands-off sponsor or typically the originator, these are the people who just need to be kept informed to understand how things are going. And so we can create a diagram like this to try and chart that, to keep a list so that we know who to reach out to and how we need to interact with them. All right. So this is a part of that human resources plan also. Are we going to keep a chart like this? Personally, I don't like these charts just because if you have 4 people on your project, this chart works great. But what if you have 400 people on your project? This chart's useless. And so, I'll normally do a slightly different arrangement. Basically what I like to do is when I do the WBS, the work breakdown structure, in my WBS dictionary, for each work package, I've got information detailing that package in the WBS dictionary. I list who is responsible, accountable, and so forth in there as part of the WBS dictionary. You can do that. Remember, all of this stuff is modular and flexible. The larger projects are not going to lend themselves well to a chart like this. All right. So those are some of the different things that are available to us in there. We've got other simple things like expert judgment and meetings that we've seen over and over again. But basically, we're specifying in here how we're going to get these people, how we know how many people to get, and what process we're going to go through. The end result is a human resources management plan, which is far less detailed than you'd think, because we're not actually getting the people yet. So it's really detailing what we're going to do in the future. When it comes time to get people, how do we get them, right? That's what's in our resource management plan. So let me pull up a sample of a resource management plan.
2 down.
Human resource management plan. There we go. And so what you'll see in here is attached to your project, who is attached, what their role is, their responsibility, their authority, right? These are generally people that are a part of like your project management team, but it's also going to include things like your PMO, if that's where you're getting people from, or your human resources department, if that's where you're getting people from. Your project organizational structure. Now notice that's not the company organization, it's the project. The project manager is usually going to be at the top of this and how people break down underneath that. And then the most important part of this plan, the staffing management plan. How do you acquire your staff? If I need web developer 1, 2, and 3, all right, how do I do it? Well, in my acquisition plan, I might put, whenever possible, leverage internal personnel. You'll acquire internal personnel through the use of a PMO or through the functional manager for that appropriate department, all right? And then when not possible, perform a request for bid process and bring in contractors to perform that role, right? So I'm laying that out. Use internal people first. If you can't, then use external to move the project forward. And anytime you have staff acquisition, it's important that you do staff release also. Remember, these employees, if they're internal employees, they work for the company. They don't work for your project, at least not in most cases. And so in that scenario, when you're done with them, how do you turn them back in, right? And it sounds really negative, like turning in a bowling ball at the bowling alley when you're done bowling. But basically, when you're done with that person, when they're done with their responsibilities in the project, they're now free to go work on other projects. So you need a formal process for releasing the employee so that the company knows they're now available to work on other projects. You're not firing them, you're just making them available again for other projects. But while you've got them locked in, while you've got them acquired, no one else can use them unless you come up with some kind of an agreement there. For example, you might secure somebody to work part-time on your project, and so they've got more time available for other responsibilities. And that is incredibly common. So, I was a network manager for a bank, and my team, myself and the other network engineers, the way we worked is about 50% of our time was spent on projects and 50% of our time was spent on maintenance and operations. And so in any given day, we only had half our time to work on projects. The other time, it was spent maintaining and monitoring our networks. We were always split between those two roles. Very common. And so you need to make sure that's set out in your plan. All right. Some of the other things that we might include in here, if we're gathering people together, their resource calendars, if we've collected them, I wouldn't normally put them in a box here. They'd normally be like attached as appendices. Any training requirements, it might be that I need personnel and I could contract it out, but I could train somebody internally to meet my need. I need to do a cost-benefit analysis. The advantage of training somebody is that they're then available to help with other projects in the future and avoid that outsourcing requirement. Rewards and recognition. When somebody successfully completes the project, as a project manager, you may not have hire, fire, and evaluation roles. You might not have the authority to give somebody a raise, but by building it into our plan, we can get our sponsor to sign off on it, and our sponsor may have that authority, usually does have that authority. So any kind of rewards or whatever you might be planning, you build into your plan. Then any regulations and standards, this comes right from enterprise environmental factors, there we go, EEF. It comes straight from those. We basically punch in anything that we have to live up to. And safety, right? In the United States, we have OSHA. Every single business, 100% of them, has to comply to the, Occupational Safety and Hazard Administration? There we go. So one of the few acronyms that I got on the first try. So those are things that we have to live up to. We put those in the plan too. You'll notice that all of this is pretty generic, right? So if you keep it generic enough, this human resources plan is then able to apply to all of your projects. You just reuse it. So you typically only have to draft this one time and then just keep it up to date. All right, so that is pretty much human resources management. Our outputs of this process are the human resource management plan. We're not acquiring people yet, we're just planning for it. And you'll notice that we've got plan human resource management here in planning. In execution, you've got to acquire the team. If we acquire the team now in planning, we're not ready to start the work that we have them assigned to. So we do have our project management team. Notice over here, it doesn't say acquire the project management team. It says acquire the project team, develop the project team. The project management team is already in place. They were put in place back here when we were dealing with our scope and so on. You know, in order to get that stuff going, once our charter was signed, that's where we got our project management team. So, all right, so keep that in mind, and that's pretty much human resources. All right, we got one more area that we want to jump into, which is our communications management plan before we wrap up this episode. So let's do this. Let's stop here and take a break. Okay. And when we get back, we're going to dive into communications and take a look at that, kind of see what's involved, and we'll wrap up from there. So stay tuned. We'll be back in a few. All right, so for our last process this afternoon, we're going to take a look at planning communications management. Right. Now, we talked briefly about communications back at the very beginning of the project. We created a stakeholder register where we listed all the stakeholders of our project and we put some basic information about how to communicate with them. But now we need to refine that. A lot of that was done early on in the project and we've learned a lot more now. The main thing we've learned is that we've got a lot of work packages that have actual workers attached to them that we're going to have to communicate with, not necessarily the stakeholders we identified earlier. So we got a whole slew of new people attached to our project, so it's time to revisit that. Revisiting the communications management plan is one of the things that I like to do later in the planning phase, because the more planning you do, the more people you find, and so this is one that's constantly getting updated. So I like to do a final pass before we move into execution, just to make sure that I've got all my people listed. You'll see the inputs on this one, the project management plan, again, if we have it, that makes this easy. The stakeholder register, that is really where all of our information is going to come from. And then enterprise environmental factors and organizational process assets, like we've come used to seeing. All right, on the tools and techniques side though, this is where things get really complex, because what you're trying to do is you're trying to come up with a plan that defines how you communicate information about your project to other people. And that's a big deal, right? If you are working on a government project, You may have to report to the Senate or the House, various committees. You might have to report that information in certain formats, in certain intervals that they define. If it's just an internal project, you may have your own calendar that you follow of what information you disseminate, how you disseminate it, and so on. And that stuff needs to be agreed upon ahead of time. And that's where our communications plan comes in. So it can be very, very simple, but it can also be very incredibly complex depending on how crazy you want to go on it. All right. So we start by doing communication requirements analysis. And that's basically where we take a look at our people in our project, and we determine what type of communications we really need to provide for this project to be successful, right? So what's the bare minimums? And you'll see a ton of possible things to think about. Ronnie, you've been exhaustive here in your list. So for example, when we reach out to people, we might have specific communication methods that we want to use. So we have potential communications. We might have email, fax, phone, physical meetings, online meetings, mailers, all sorts of different communication methods. We need to identify what people are attached to our project and which of those communication methods is suitable for them, right? If I'm giving a status update to my key stakeholders, a physical in-person meeting might be the best way. Get them in a room, sit down with them, and say what's going on. But if I'm communicating with the general public as a whole, I can't call them in for a meeting. So for them, maybe a mailer is the way to go, or maybe a email or something like that. I need to determine the methods that are appropriate for reaching out to them. All right. Now, Ronnie put in a formula here, and this formula has been a part of the PMBOK for a long time. And what it is the potential communication channels or paths, right? When we think about projects, it's really easy to think of it as everyone talking to the project manager and the project manager talking to everyone. So if there's 50 people attached to the project and I'm one of them, then there's 49 paths. Me talking to 49 people talking to me. But that's not really it, because people within the project may talk to each other without going through me. So when we talk about communications, there are several paths that occur. And so there's a simple formula for that, and it's not the most terribly useful one, but it does show up on the exam from time to time, so it's good to highlight it, which is basically giving us a way to figure out how many people, or how many paths of communication may exist. The N simply equals the number of personnel, it's two N's. There we go, personnel or stakeholders that are communicating, right? And we just plug it in. I gave an example of 50, right? So if we said 50 times 50 minus 1, all divided by 2, right? So we do 50 minus 1 because, well, somebody's not going to talk to themselves, so we have to reduce it by 1. So we take 50 times 49, and we divide that by 2, and that's going to give us the total amount of paths, and that's not a number I'm going to be able to do in my head. So let's fire that up in here. So 50 times 49,
2450.
And we'll divide that by 2. So 1,225 different communication paths are present. All right. Now that you have that information, what does it mean to you? Well, if you're like me, it doesn't mean much, right? That's why I say this is not a terribly useful method. But what it's doing is it's giving me a warning. It's saying, look, in your project, communications can be very complex, because there's 1,225 different combinations that could occur as people start to talk to each other. So are we going to plan for every single one of them? No. But what we're going to do is we're going to plan for the major lines of communication, how we talk to the project team members, how we talk to the project members, how we talk to the stakeholders, how we talk to the sponsor. Those are all key communications, right? And we need to plan for how they're going to be handled. If we plan for all 1,225 lines, we'll be in the planning phase forever. All right. So in order to understand those key communications, we need to know our organization. So organizational charts are something that we'll look at as we figure out who's talking to who. If I have 3 web developers, I might not want to communicate directly with all 3 of them, but instead have a team lead or have the functional manager for the web development team and communicate with them. That way I'm talking with one person and they're controlling the input and output of data to those 3 people underneath them. that really simplifies things. I know mid-level management gets vilified in comic strips and movies all the time, but the whole purpose of mid-level management is to allow us to easily communicate with large groups of our employees without having to deal with them individually. So they better understand the language and method to communicate with their employees so that we don't have to. And so this is one of those areas where mid-level management comes in really handy. All right. So some of the other things that we're looking at are our project organization, which again might differ from our organization, disciplines, departments, and specialties involved in the project. So if we've got employees divided up different ways, normally those are departments or disciplines, we need to be able to reach out and communicate with them. If we're contracting, then we might have people that have specialties, and you'll see this with employees too. I might have 3 web developers. One might be an outstanding PHP developer. The other 2 might be outstanding CGI developers or something like that. And so in those scenarios, I've got different specialties, so when I communicate, I need to make sure I'm talking to the right people in a way that they understand. All right. So that's really what we're juggling. And when we start drawing our lines, our communication methods, we're going to have our internal and our external methods. Internally, we're talking with our own employees, generally people on our project management team and our project team. Externally, we're generally talking to our contractors and the press, right? You might be talking to your customer base. So for example, if you're doing a project that is a road reconstruction project, right? So you're repairing some roads, you might want to communicate out to the citizenry to say, hey, this road's going to be closed for 3 days. It's part of our ongoing project to make the town better. So you put a positive spin on it while informing them that the road is going to be closed. That's the kind of communication that needs to go out. And we need to say, what's the best way to communicate with them? It's going to be different than how we communicate with internal employees. All right. And then our stakeholder information, what you're going to find is that each stakeholder might have their own preferred method of communication. I used to work for an insurance company, and the president of the insurance company hated email. Just he didn't like computers in general, but hated email. So whenever you send him an email, what would happen is he had a secretary who would print the email out. And when he'd come into the office in the morning, he'd have a stack of papers on his desk that he would read just like they were letters. Like he had been doing for 50 years, that was what he was used to. That was how he liked to communicate. So I knew if I sent him an email, he wouldn't read it until the next morning after it was printed out on paper, and then he read it in the morning. So email for him could have as much as a 24-hour delay. So if I had something urgent that needed to go out, I got off my butt and I went up to his office, or I called and I scheduled an appointment with the secretary to be able to go up there and talk to him. That was how he needed to be handled. It was not wrong, you don't have to use email. It was just how he liked to do it. And so I knew that in any project, if I had to communicate with him, email was fine if I was okay with waiting. If I was in a hurry, it wasn't. That's the kind of stuff that needs to go into our communications plan in our project. All right. Now, where this gets really fun is the next one, communication technology. What are all the different ways we can communicate? Email, fax, text message. Good God, text messages. So you see, now here's where I start to show mine. I hate text messages. If somebody texts me and I don't get it, I don't care. And they say, well, I sent it to you. And I say, well, it's your fault for sending me a text. I don't like text. So, different people communicate different ways. We need to know the appropriate technology, right? Fax, the facsimile, it's a great system, but who has a fax machine anymore, right? Aside from the government. So, it's just not something we see very often. So we need to understand what technologies we want to even allow in our company. There might be some means that we don't allow. You're starting to see this in the medical industry a lot now, where they're blocking email. No communications via email, because email is non-encrypted by default, and they worry about patient records making it in there. So you may have that kind of thing in place, so you've got to make sure that you've got that documented. All right, communication models. Communication models are different ways to reach out to people, and PMI breaks it down into 5 categories, right? We've got encode, transmit, decode, acknowledge, feedback, response, right? Feedback and response are kind of combined, all right? So starting out encode, we have information that we need to give to people. But to us, it might be a Gantt chart. It might be a resource sheet. It's project management speak. And when we start communicating out, we'll see this with earned value analysis later on. If I start talking to the CEO about EAC and BAC and all these other numbers that we deal with as project managers, we'll see all these in monitoring and controlling. When we start talking about that stuff, their eyes glaze over. They don't know what you're talking about. They haven't seen these formulas. They don't know what they mean. So I've got to translate it.
Right.
I've got to encode this data in a way that I know the recipient will be able to interpret it. Don't use project management specific terminology. Use terms that are understandable within your company. Transmit. How do I send the data? I need to get this data to the people, and I do it via phone, email, whatever. That's something that I've got to come up with the communication model for that. Decode, right? They're going to receive it, and they're going to interpret it. If it's an email, they're going to open up and they're going to read it. And I need to understand how they're doing this. If it's a voicemail, you hear my voice, you hear tone, you hear inflection. It's very easy to understand what I'm saying. Well, except for the fact that I have terrible speech. But if I send you an email,
Don't know.
no inflection, no tone, you don't know. Am I angry? Am I happy? I've got to make sure that I properly address that. Use the right adjectives and verbs and stuff to make that message carry the information I need. Acknowledge. This is a big challenge. If I send somebody an email and I say, here's a problem, you need to do this to fix it, and then they don't do it, right? And I come to them and I say, why didn't you do this? I told you. And they say, I didn't get the email, right? I didn't get the voicemail. Well, that happens a lot, and the majority of the time they did get the email or they did get the voicemail. So we need a way to acknowledge that. With email, you have read receipts. They're not the most trustworthy. So if there's a case where I need absolute, what they call non-repudiation, right? The ability or the lack of ability for somebody to say they didn't get it, then we might need to do registered mail or signature required, something like that where they have to sign off on it. I might require a phone call so that I can have a phone call recording, or I keep a phone log that says, yes, I talked to this person at this time, at this date, this is what was agreed upon. That's very important, and that's acknowledgement. And then lastly is feedback and response. If you're sending out a communication, you probably expect some kind of information back. Not always. Maybe it's a status report, everything's going great, no actions required, that's it. But if there's even the slightest deviation, then you may expect some feedback. And so in your communication, you need to specify the best way to receive that feedback. If I'm reaching out to the public with a mailer, I need to put in there, hey, if you have any questions, call this 1-800 number we've prepared to answer any questions you have. So you specify a way to provide that feedback, an acceptable channel, right? Because you don't want people just communicating however they want. We get that like, IT Pro TV, I am amazed at the way that our viewers reach out to us. So we set up our Q&A forums and our live chat for you guys to be able to ask questions with us, right? And so those are our communications methods. But over the years, I've gotten where people have reached out to me through all sorts of things. I get LinkedIn requests, even though I don't have a LinkedIn account. I got a Google Hangout once. It was actually kind of fun. I talked to one of our viewers and helped them out, all via Google Hangouts. I never even thought about it. I just, it's just ways that are out there. So understand that if you leave people to their own devices, they'll communicate with whatever way works for them. You might not be expecting. You might miss that communication, and now they think you're ignoring them, right? I would have hated for that to happen. Somebody sends me a message and they think I'm ignoring them, but it's just, it came through a channel I wasn't expecting. So in those scenarios, if we had just laid it out in our communication and say, hey, do you have feedback and response? Here's how you send it to us, and feed that information to them. So that's an important part of that communication model. All right. And then on our methods, well, we've got interactive, push, and pull. Interactive communication, it's like a phone call. I say, hey, Ronnie, what do you think about this? You tell me,
that's it.
I respond, right? So straightforward communication there. Push and pull, though. Push, I tell you, I send something to you. It's like a mailer, right? When I send you a letter in the mail, you read it, you can't really respond to me right then. You've been given one-way information, right? And then pull, that's where I reach out to you or you reach out to me and you say, hey, Don, I need the status update. Tell me this. Tell me what I need. Okay, and this might be a written letter, a subpoena, those are the fun ones, something like that says you've got to provide us with this information, and we provide it. So pull, in theory, if there's ever a pull going on, that means your system is broken down. That means that there's something that you didn't account for. If somebody needs some information we should have identified that early on in the planning phase of our project so that we knew to send it to them. But if they're doing a pull, if they're saying, hey, I need this data, then that was something we didn't plan for. So we need to do we really need to do two things. One is give them the information they want, right? Always give people the information that they want. There's nothing that we should hide. And then two, do a change ticket to update your communications plan to say, this person did a pull request for this, so going forward, we need to send them this information at regular intervals so that they've got it, so that they don't have to request it from us, that it's already prepared. It becomes part of our plan. All right. So these are all some of the different things that we have to think about. Once we've come up with everything that we need, then we have meetings, right? Meetings to discuss communications. That's always fun. Meetings to discuss what kind of meetings we want to have. But once we've got all that figured out, now we have a handle on how we need to communicate throughout our project. And we're able to draft our communications management plan. That plan is going to basically dictate how we communicate. One thing we may have learned as we were doing this was how people want to be communicated with. So we may need to go back to our stakeholder register and update that, if that's where we're keeping track of it. So we've got our project document updates here as we continue to update there. But let's look at a communications management plan. I've got a few templates on this one. Or actually, you know what? Maybe I don't. So if I've got communication management plan at a minimum. So this is what a communications management plan looks like. We've got our stakeholder, the information that they need, the method that we send it to them, and the timing frequency, how often we send it. And then just who's responsible for sending that data. This is the key set of information we need as part of our communications management plan. Who we're reaching out to. Now, this may not be the same across every project. So when you have that plan that serves as a template plan, you may have your default data in here. So it might say key stakeholder is the project manager. All right, and you might have project sponsor. And so these are really just generic terms that are going in our plan. And I might say that they get all information. And here we get regular status updates. And then we can put, how they're getting it: phone, meeting, email, fax. Whoops, if I can spell fax. Right. So all the different ways that they communicate, and then we specify the timing. Right. The project manager, that would be constant, just as information comes in. But the project sponsor, we might be giving them weekly status updates, and the sender for that is going to be the project manager. And up here, this would be the project management team. And so we just fill that out to be appropriate for what our company needs, right? Each of the different elements that that needs to be sent out, we document it here, and here it's high level. So when the project kicks off, I take this plan and I say, okay, well, you know what? I'm the project manager, so I'll just sub my name in there, right? And then the sponsor is Ronnie, and so I punch his name in there, and now it becomes the plan for my project. And then I add. You'll always have to add, right? Because you've always got different stakeholders with every project. So we'll have to add people and their communications too. Any assumptions and constraints come in here. There's some information that we just can't provide in as timely a manner as people might expect. So maybe they're asking for daily status reports, but we don't have the resources to do that. And so we put in here that daily status reports are not possible. That's a constraint we have. Any assumptions that we make, we assume we got everybody here. But if we didn't, we can add them in using a simple change ticket. And then glossary of terms or acronyms. You see this in the military. We might have as a method, we might have email and actually we might do like SIPRNet, right? Or NIPRNet or whatever, which in the United States military, they have two networks. One is a secure network that's isolated, and one is a non-secure network that isn't isolated from the internet. And so when they communicate, if it is a secure communication, it's supposed to go over SIPRNet. If it's not, then it goes over NIPRNet. And so I might put that glossary down here and say, here's what those stand for. Here's what the SIPRNet means, and so on. So I just lay that information out. All right, which I think I used the wrong acronym there, but whatever. So that's basically some of the stuff that's going to go in this communication management plan. Now, I normally couple this with my stakeholder register, And it's up to you, and I think I didn't do it here in my template, so let me pull that up. Stakeholder
One more.
management plan
I thought you were
here. So where we've got like our stakeholder, and I did do it. So communication needs,
there it is.
method and medium, timing, frequency. So you may have some of this in your stakeholder management plan already, in which case you might not need that separate communications plan. Again, it's up to you. You can merge this stuff together or keep it split apart like this. So what I'll typically do is like here in the stakeholder management plan, these will be like my project team, my main stakeholders. But then in my other one, my communications management plan, which I closed, this one I'll go all out and just have everybody, all the various people that are doing work in my projects. This might be much larger, and this is probably what I refer to more frequently. So entirely up to you. All right. So that pretty much wraps up communications management plan. Not a whole heck of a lot to think about there. We could really sum this up into a couple of sentences. Who do we need to talk to? How do we need to talk to them? And when do we need to talk to them? Right? I mean, that's basically all we need to know. I guess you could throw a what. Like, what do we need to talk to them about? That's about it. So we try and plan for that. Understand that this is a very living document. This is going to change as your project goes on because new communication needs pop up. Well, fortunately, communications like these don't normally cost us a lot of money or even a burden. And so making changes to this plan after we're in production, after we're executing and all that, is usually not a big deal. So just be prepared for that. Changes will happen. All right, well that knocks out a pretty decent chunk right there. So we just tackled quality management, human resource management, and communication management. We still have risk to get through and then a couple other little ones, so we'll tackle those in our next episode. But for right now, that's a pretty good spot for us to wrap up for today.
Sounds good.
All right, well, let me just remind you guys, if you have any questions on this stuff, live during the show, you can go to itpro.tv/live. You can post in the chat room. We monitor and answer live during the show. If you have questions after the show, use our Q&A forums. At the top of every page, you'll see a link that says Q&A. It'll take you into the forums. You can post your questions there. And again, we monitor and answer. All right, well, I hope you guys enjoyed the show. Signing out for IT Pro TV, I'm Don Pizzette.
And I'm Ronnie Wong.
And we will see you next time.